Class, this video is going to help with 4-4, which is our counting idea. We've done a little bit of this, but now we're going to focus on it a little more and more in detail. So multiplication counting rule, it's sometimes called the fundamental counting principle. Counting principle. Okay, that's another word for it. And it's basically multiplication rule for a sequence of events in which the first event will occur in one ways, maybe that's 5 ways. The second event will occur this many ways, third event, and so forth. You multiply them together. So a quick example, if I get up and I have 2 pairs of pants and 5 shirts, how many ways can I make an outfit? I would times those things that I have together, the 5 and the 2, right? So I'd have 10 outfits. That's kind of the idea of this one, is like I can times the number of options to get the total ways, and that would then probably be my denominator for a probability. That's how it's relating. So some of your questions will ask how many total ways, and some will then add that probability on it. So let's look at this one. When making random guesses for an unknown 4-digit passcode, each digit can be 0, 1 through 9. What is the total number of different possible passcodes? Stop there, right here. What is the total number of possible passcodes? Well, how many digits do we want? 4 digits. How many ways can we do digit number 1? 10, right? 0 through 9, 10. So digit number 1 is 10 ways, okay? And then we have 4 digits, right? And how many ways for that second digit? 10 ways. Third digit, 10 ways, 10 ways. We didn't change anything. And then if we think about this, we times the ways together to get 10 to the 4th, which just makes 4 zeros. So 10,000. Given that all of the guesses have the same chance of being correct, what is the probability of guessing the correct passcode on your first attempt? Okay, so the probability on your first attempt of so first try, correct, however you want to think of that. What's the probability? 1 out of 10,000. What if I gave you 10 chances? It'd be 10 out of 10,000. Okay. This kind of relates to lottery a lot too. There you go. That's the idea of counting. So I can do it with outfits. I mean, they don't have to be the same on each one. It can be, what's another one? Like maybe you have a letter and followed by 2 numbers in a passcode. So the first letter you would have, why did I just forget how many letters there are? I can't even think of it. Oh, that's silly. Is it 32? Is there 32? Why can't I think of that? Yeah, there's 32, right? Whatever. I give up. I can't even Google it. I can't. All right. So you would have however many ways for the letters times 10 times whatever I said. So you could mix it up and not every single one be the same number. I can't believe I can't think how many letters there are. Whatever. You know how it is, like sometimes you're like, and I just made it, this is like my 4th lecture for today, so like that's part of it. Okay, so let's move on. So you can multiply your possibilities together. Again, lots of multiplication involved in probability. So what is this factorial rule? So factorial is an explanation point, just like you see here. And it's the number of different arrangements, order matters. So it is, you can count down on something if order matters. So think of this one's an example with 6 factorial. It's just basically saying you're going to go 6 times 5 times 5 times 3 times 2 times 1. We definitely don't want a 0 because then it'd be just 0. So think about what are the top 6 placers from a race? They're all going to be different. So the order matters because you want to get each person individually. So you'll have 6 options for this, 5 options, 4, 3, 2, 1. If you have 6 people and they're placing, you have to have 6 people. Otherwise, it's going to be a little bit different problem. So it could be like 10 people. How many ways can they show up to an event? 10. Then you have 1 person show up. So then you have 9, 8, 7, 6, 5, 4, 3, 2, 1. So it could be something like how many, but it's like the total number of people. But I really want you to look at the factorial idea also for the formulas for permutations and combinations. So what is a permutation? It's similar to a factorial rule because order matter, but factorial is just this simple. So I don't want to confuse too much. They call this kind of our factorial rule, but a factorial is this number. So factorial rule is a little bit different than just a factorial, I guess. So through. Factorial is just this little explanation point. It's basically I'm lazy and I don't want to write 6, 5, 4, 3, 2, 1. I mean, especially if it's 20. So we just use that symbol. So permutation, when n different items are available and 4 of them are selected without replacement, or an R of them are selected without replacement, the number of different permutation is given by this. So what am I really saying? I'm saying I have a total number of this and I want to choose 4, but the order matters. So think of a race where I'm not just having 6 people or 10 people, I'm having 1,000 people. How many come in? I want the top 6 out of 1,000. That is the difference between this one and the factorial rule. This one is letting you have a different number to start with. So N is your total, R is how many you choose. That's our formula, write that down. It's also in your calculators. Like I have 2 different calculator options. This one here and like this basic one, it's under probability right here. Turn it on, probability, let me clear whatever's on that. Probability, you have N factorial or P and the C and the regular factorial. On this calculator, it's under math over here on the left. And you just go over to probability, oops, and you can see the 3 here that you'd want, okay? And I'll give examples of this in a minute, but that's what it's given by. Another kind of weird one with permutations is sometimes you have something that repeats itself, like it could be how many ways to arrange letters or numbers. If you have some of them that are repeating, I have to do the total number and then each repeating one will be down here. Like for example, if I have 2 2's in a problem, I would do 2. If I have 4 3's, then I would have 4 factorial, 2 factorial, 4 factorial. So it's however many repeat you would have to put on the bottom with the number of repeating factorial. Again, I'll give you an example. So these are our basic ideas with permutation, and all 3 of these are order matters. So coming in, vice president, president, the way I sit in chairs, I'm trying to think of any other problem. Some lottery might also be this way, bingo. The next one would be basically the same idea, but order doesn't matter. So notice the formula has an extra R on it. Basically, it's going to take off an extra choose factorial because there isn't as many ways. So if order doesn't matter, there is not as many ways to come in. So if I just want to pick the top 6 place people, top 6, I don't care what order they came in. It's a lot easier to pick, or it's easier, but it's a lot less combinations than if Joe was first and then Mary and then Bob, and then you could have had Mary, Bob, Joe, you could have switched those all up. So with order mattering, there are a lot more ways than a combination. Okay, when n different items are available, so n again is your total, given or choose for without replacement is the idea. Okay, or order doesn't matter. Let's use these. So I put in kind of a lot of examples just because I think this section people get it a little bit confused. So a horse race, a trifecta bet is won by correctly selecting the horses that finish first and second and third. So you go and you bet and you say, that horse is going to get first, that one's going to get second, that one's going to get third. And you must select them in the correct order in order to win. The 140th running of the Kentucky Derby had a field of 19 horses. How many trifecta bets are possible? So how many total bets are possible? So I have how many choices for the first place? So think about this first. Does order matter in this problem? Yes, because we're specific. We're not being generic. We're like first, second, third, and in the correct order. So see how I'm being really specific? That's going to be a permutation, so order matters. This first one isn't asking you can just use the idea of you have 3 ways, what's it called, the factorial rule. So it's like I have 19 ways for the first one, I'd have 18 for the second, and I would have 17 for the third, because it would have to count down. You'd have to lose one each time. And it wouldn't be a full factorial because I don't count all the way down. So I guess, so it would be 19 times 18 times 17 is going to give me 5,814. So I could also think of this as 19p, I have total 19, choose 3. So if I put that in the calculator, I'm going to have 19, choose 3, and I get the same number. So you could think it through this way, or you could do the permutation of it also. In a calculator is fine, but what was our rule for it? It was n factorial over n minus r factorial. So n factorial total over n minus r factorial. So I could do the formula out as well. So then you could do 19 factorial in your calculator. So I could put it in as 19 factorial like this, divided by 19 minus 3, and then add in the factorial, and you better get that same solution. So why do I show it 3 ways? Because I prefer to think through the problem with all permutations, and I just think 19, 18, 17. If you want, you could think of it 19 choosing 3, and that might be a better way for your brain. And then you use that P, because you know the order matters, and then just use your calculator or the formula. Okay, if a bettor randomly selects 3 of those horses for a trifecta bet, what is the probability of winning this California Chrome to win, Commanding Curve to finish second, and whatever to finish third? They're being very specific, as they did. Do all the different possible trifecta bets have the same chance of winning? Okay, dead heat is just where there's a tie. All right, so what is the probability? It's going to be 1 over 5,814. So that's going to be our probability of picking that trifecta. Your chance is 1 out of all those different ways for them to come in. So the more horses, the less likely you are to win, because you have more to choose from. Totally makes sense. Do all the different possible bets have the same chance of winning? That's such a tricky question. Yes, in general, yes. But not really, because you know some horses are faster than others and they're ranked differently. We're going to ignore their ranking. We just say that they're all equally likely. So, but in real life, no. But for this example, yes. If we say all horses run equally, we know no other information, they are equally likely to win. Well, I guess, or you could think of it as like, really, it does have a chance to win, even if it's never ran that fast ever in its entire life. It still has that chance. Okay, so this was all a great example of a permutation where you calculate something out and then you use it for a probability. So this next one, I bet, uses a combination because we just did permutation. So California's Fantasy 5 lottery game, winning the jackpot requires that you select 5 different numbers from 1 to 39, and the same 5 numbers must be drawn in lottery. The winning numbers can be drawn in any order. Well, first of all, they told us it doesn't matter the order, but when I just say pick 5, am I being specific? No, I don't say they have to go in specific order. And this is the way lottery typically is. So how many different lottery tickets are possible? So it's a combination. How many numbers do I have? I start with 1 and I count to 39. So I have 39 possible. And I want to choose 5. So I can do the formula. Now, could I multiply it out like 39, 39, 39? Well, let's see if we can think it through like we could for the one before. Let's do our combination. So if I look at the formula, it's on my other side, excuse me for just a sec. Here's our our combination, and we have the n factorial, but we have that extra r outside. So we're going to do 39 factorial over 39 minus 5 factorial, and then we have an extra, which one? R, our choose, right? So that's going to be our 5. Right? We could put that into our calculator like we see it, or the original. I'm going to go ahead and put this one in just because I have it there. So 39 over to my factorial symbol. I got 39 factorial divided by 39 minus 5, back to that factorial symbol, times 5, another the factorial is going to equal a massive number because there's 39. So let me try it this way also. So I'll write that down just a second. 39 C, I got to go to combination, choose 5. Oh, maybe I did this formula wrong then. Is 5, 7, 5, 7, 5, 7. Let me try that again. So 39, I wonder if I needed parenthesis. Probability or factorial divided by parenthesis for this whole bottom. This is, I think I know what it did. I was like, man, that was bigger than I thought. Minus 5, add in my factorial. And then, oops, somehow I forgot my second and insert. I need another parenthesis there. And then I need my 5 factorial. And then another parenthesis. There we go. So what did I do? I didn't put a parenthesis around the bottom. So what it did is it took 39 factorial divided by 39 factorial, and then, or the 39 minus 5 factorial, and then it times by the next one. Be careful. Parenthesis around the bottom. Glad I did it, and we can see that. So there's our possibilities. So 575,000 different ways for those to be chosen, for those numbers to be chosen for a lottery. What's the probability of winning it if you only choose one ticket? It would be 1 out of 5, 7, 5, 7, 5, 7. 1 out of that total. Oops. So, oops. If I did this as 39 to the 5th, because I have 5, it will not work. So you can't do a shortcut way like I did logically on this one with a combination. It just doesn't work. So think of it as 39 choose 5. See how I automatically didn't even start a shortcut way? So make sure you use the formula for this one, because you have to divide it back by, I wonder if I divide that back by, but I'm not going to give you, right? Isn't that going to work out? No, not quite. Okay, so find the probability of winning the jackpot is 1 ticket. So what if I would have purchased 1,000 tickets? Then it would be 1,000 out of all that, because you'd have 1,000 different chances, right? And the real probability also has that Powerball that's chosen, and that's like another number. And so then you'd have to take each probability of the first one and the second and times them, so you would even get less of a chance. I mean, if you divide that, that's a pretty small chance to win. I have so let's move on. I have a 6-digit code to get into my gradebook with the numbers 1 through 4 allowed. Repetition of digits is allowed, obviously, because there's only 1 through 4 allowed and you have 6 digits. But what is the probability of guessing on the first try? So for this one, I have a 6-digit code and I have 4 numbers allowed. So 6 digits, 1, 2, 3, 4, 5, 6 digits. And I have 4, 4, 4, 4, 4, 4. I have 4 ways for each one. And I'm being specific, so it has to be a permutation. So I can, because it's a permutation, I can logically think through this, or I could think I have 6, choose. No, I have 4, choose. Okay, so I have 6, choose 4, 4 to the 6. So can I do 6, choose? Oops. 4, choose. I have a 6-digit code. 1 through 4. I don't think you could do it with a permutation. Because I think you have to think of it with the way I did. I was trying to think, because you don't have a total, I don't have a total digits. You have to think of it as I have 4 times 4 times 4 times 4 times 4 on each option. So this one has to be a fundamental counting principle one, because I don't have a total number to choose some from. I was trying to think with permutations, but you can't because I don't have a total number. So for this one, I'm going to do 4 to the 6th power, and I'm going to get 4,096. So there's 4,096 different ways to do a 6-digit code with only 4 numbers. Had I put 10 numbers, it would have been even harder to get my code, which makes sense. And so what's the probability of getting it on the first try? Would be 1 over 4,096. Okay, that's your probability. I remember that's why I put that one in there. It's because it kind of was a little bit different. So number 4, presidential candidate plans to visit the capitals of 4 out of 50 states. What is the probability that she selects, she or he, either one, selects the route of 4 specific capitals? So see how we say 4 out of 50? So we have a total, so we're going to do combination or permutation, whereas the other one just said, digits, so it was like multiplication rule. So if we look at this one, we have 4 out of 50. Is it a combination or is it a permutation? We know it's going to be 50, choose 4. It says a specific route. So it has to be a permutation because you're going to have a specific route. I'm being specific, so it's going to have to be a permutation. So I'm going to do that in my calculator of 50, choose 4, and I'm going to get a huge number, 5527200. So 5,527,200 specific ways to only go to 4 out of 50. We don't have a probability question on that one though. What is it? Nope, we do. She selects the route of 4. So then if we want the probability, it's 1 out of 5,027,200. I thought it just asked though. This is our probability of her doing a specific route. Because it's different if I go Denver, Cheyenne, Boise. I kind of think of capitals I know all of a sudden. I can't think of any. Austin. Or we switch that up and do it in a different order. Those are all very different routes. So number 5, there are 25 students in a class. I need to pick 3 people from class. What is the probability I picked a specific team? Okay, so we have 25 and we just want to pick 3 people. Do we really care the order of those 3 people? Do we say we wanted it to be president, vice president? I don't like that I wrote the word specific team here because I think that was a little easy. So if we have 25 people, choose 3. 25, choose 3. Does order matter? Yes or no? No, I just pick 3 people. I don't care if it's first, second, third. So it's going to be a combination. So 25 combination, choose 3 is going to be 2,300 people. And then the probability of picking one specific one is 2,300. 1 out of that. So there's less with the combination. Had I said it as I need to pick a president, a vice president, and a secretary, then I would have been being really specific and I would have needed a permutation. Okay, I feel like that word specific shouldn't be there. Pick the team. I just think I'm trying to get you to recognize when I'm being like really wordy, it's more of a permutation and then that word, or you're being specific. Okay, so one thing we haven't looked at is any repetition. So let's use the word Mississippi for repetition. How many ways can the letters in Mississippi be arranged? I did not ask about probability. Just how many ways can you arrange those specific letters? Well, we have this S and this I and the P that repeat themselves. So what we look at is how many total letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 total letters, and you have that as your total on the top, factorial. Then on the bottom, each one that repeats, you have to do as a factorial because it'll make it less ways to be arranged. So are there any other M's? No. How about I's? Sure. 1, 2, 3, 4 I's. So we have 4 I's represented right here. Then we have S's. We have 4 S's being represented there. And 2 P's being represented here. And we've covered all of our letters. 4, 8, 9, 10, 4. And then we had 1 that didn't repeat itself. So I was just counting to make sure we got them all. Then we can put this in our calculator, and that's how we would deal with repetition. Okay, so 11 factorial is a big old number. And then I'm going to divide that by, I'm going to use a parenthesis around this so that it divides all of them. 4, and then you put in your factorial times another 4, and then put in your factorial times a 2, and then put in your factorial. And I get 3, 4, 6, 5, 0. So it just asks the number of ways you can arrange it, 34,650. So no probability question on that. Another one that's just arrangements. How many people could use one area code? How many people can use one area code? So let's think of our, we have our numbers. We have 3 numbers for our area code. And then we have 3 numbers, and then we have 4 numbers. That's kind of how your phone numbers work, right? So how many numbers are completely in an area code? There would be 1, 2, 3, 4, 5, or in a phone number, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 numbers. And how many ways can you pick each one? Well, think of just 307. Well, I wrote down 10, but if I want a specific area code, see how these numbers could each change? How many options do you have for this first one? 10, 10, 10. They could have restricted you, like you can't, your number can't start with 0, but wouldn't it be cool to have the phone number 0000000? You actually can't, because 0 is an operator number, or it used to be, so it wasn't possible, but we aren't going to look at that. So these 3 numbers would stay the same, so we don't have 10 changing digits. We only have 7 changing digits. So I would use my multiplication rule, and I would times these 7 numbers. So I'm going to do 7 to the 10th power. I mean, I did that wrong. I mean, I said it wrong. 10 to the 7th power would be 1, 2, 3, 4, 5, 6, 7 zeros. So it's going to be 10 million people can use the same area code. That's a lot of people. 1, 2, 3, 4, 5, 6, 7. Yeah. If they changed it up, like you couldn't start with a 0, there would only be 9 options here. That's how it would change it, and it would just be a little smaller, not very much. If something like that was said. Okay, what are our big takeaways for this section? The big takeaways are that your teacher was tired when she made this video. The takeaway is permutation is really specific and your order matters. Like order in which you have something be presented, the order that you show up somewhere. Combinations are non-specific. I have 20 people and I want to choose 2, non-specific. Both permutation and combinations have your total numbers and you're choosing so many out of that. 1,000 people choose 50, okay? 1,000 people choose, the top 3 finishers, permutation. Then we have our multiplication rule that we've used on a couple different questions, and that is just multiply your options together. Think of how many you have on your options, how many you have for each one. So I use a little lines. So, on the one we just did, it's 7. So we had a little 7 lines, and we had 10 options for each one. Multiply. So multiply. And that is our fundamental counting principle. And then we have that idea of if something is repeated, permutations that are repeated, and then you had to do the total number factorial, and then you had your however many were repeated, you divided in. All right, that was our main idea for this week, or this section.